Hello dear students, welcome back to my science class. Today I am going to teach you chapter 13 of your NCERT book, that is time and motion. You are watching the channel Learn Science with Munmun ma'am. Hello dear students, welcome back to my science class. Today I am going to continue with the chapter motion and time. In our previous class we have discussed about different kind of motion. Circular motion, rectilinear motion, periodic motion, right? We have also learned about a vehicle can be slow or fast that we can measure by measuring its speed. Speed equal to distance by time, right? And in this chapter we were taking that speed, average speed. We are discussing about average speed, that means total distance covered by total time taken. Also we have learned in our previous class about uniform and non-uniform motion, right? And we have started our discussion about measurement of time. There we have read about different type of clock and we were discussing about a simple pendulum. So in today's class we are going to continue our discussion from the simple pendulum. This is the picture of a simple pendulum. This is showing a metallic bob that is hanged from a string, and this O is the mean position of the metallic bob. From its mean position it go to one extreme A, another extreme B and come back to O. In this way to and fro motion of the simple pendulum completed. It starts its motion from O to A, then B and back to O. This is called one oscillation of the simple pendulum. That means starting from the mean position to one extreme to another and back to its mean position is the one oscillation of the simple pendulum. Not necessarily that simple pendulum always start its movement from the mean position. It can start its movement from extreme position as well. If it is starting its movement from one extreme and then going to another extreme and again coming back to the same extreme, that is also one oscillation. I hope you have understood how the movement of pendulum takes place. So a simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called bob of the pendulum. Figure 13.4 shows the pendulum at rest in its mean position. We have just now seen about. When the bob of the pendulum is released after taking it slightly from one side, it begins to move to and fro. So that movement is to and fro movement. The to and fro movement of the simple pendulum is called oscillation or oscillatory motion. The pendulum is said to have completed one oscillation when the bob starting from its mean position going to one extreme A, then another extreme B and again come back to O. And as I have said to you, if it has started its movement from A and again coming back to A after completion of one complete movement, that is also one oscillation. So the time taken by the pendulum to complete one oscillation is its time period. Now we will learn how to measure time period. So the definition is time taken by the pendulum to complete one oscillation is called its time period. Activity 13.2. What you are doing here, set up a simple pendulum as shown in figure 13.4 with a thread or a string of length nearly 1 meter. Switch off any fans nearby so that the motion of the pendulum is not affected by the fan. Let the bob of the pendulum come to the rest as its mean position here. Mark the mean position of the bob on the floor below it or on the wall behind it. To measure the time period of the pendulum, we will need a stopwatch. However, if a stopwatch is not available, a table clock or wristwatch can be used. Nowadays, you can simply use your mobile stopwatch, right? To set the pendulum in motion, gently hold the bob and move it slightly to one side. Make sure that the string attached to the bob is taut while you displace it. Now release the bob from its displaced position. Now you will not touch it and you will measure the oscillation of simple pendulum to know the time period. Okay. So what you are doing, suppose you are measure the time of the pendulum takes to complete 20 oscillations. Record your observation. I am simply giving you one example. Suppose 20 oscillations completed in 2 seconds. That means one oscillation completed in 2 by 20 seconds. That means 1 by 10 seconds. So that is the time period of the simple pendulum. The first observation shown is just a sample. Your observation could be different from this. Repeat this activity a few times and record your observation. By dividing the time taken for 20 oscillations by 20, get the time taken for one oscillation or the time period of the pendulum. Is the time period of your pendulum nearly the same in all cases? Note that a slight change in the initial displacement does not affect the period of your pendulum, right? So, the oscillation, the time period remain unchanged. Nowadays, most clocks or watches have an electrical circuit with one or two more cells that is help us that are known as quartz clock that help us to measure time quite accurately in comparison with the clock that was available earlier. Now, units of time and speed. We know the basic unit of time is second. Its symbol is S. The larger unit of time is minutes and hour. We know the conversion also that 60 seconds make a minute and 60 minutes make an hour. What would be the basic unit of speed? As speed equal to distance by time, so obviously the basic unit of speed is meter per second. But as our convenient, we can use the bigger unit like meter per minute, kilometer per minute, etc. You must remember that the symbol of all units are written in singular. For example, we write 50 kilometer and not 50 kilometers, 8 centimeter and not 8 centimeters. Bozo is wondering how many seconds are there in a day. So that is quite simple to calculate. We know there are 60 seconds in 1 minute, 60 into 60 seconds in 1 hour into 24 in a day. In this way you can calculate. Now an interesting story. There is an interesting story about the discovery of the time period of a given pendulum is constant. You might have heard the name of famous scientist Galileo Galilei. It is said that once Galileo was sitting in a church, he noticed that a lamp suspended from the ceiling with a chain was moving slowly from one side to other. He was surprised to find that his pulse beat the same number of times during the interval in which the lamp completed one oscillation. So its pulse beat equal to one oscillation. That is a coincidence, but that leads to a wonderful and very important experiment, very important result, right? Galileo experimented with various pendulums to verify his observation. He found that a pendulum of a given length take always the same time to complete one oscillation. This observation led to the development of pendulum clocks. Winding clocks and wristwatch were refinement of pendulum clocks. Different units of time are used depending on the need. For example, it is convenient to express your age in years. If you express your age in hour, it is not possible for a person to understand what actually you are talking about. It will not able to wise to express in years that the time taken for you to cover the distance between your home and the school. It will be such a fraction that we will not be able to understand actually what time taken for you to reach your school from your home. Right? So we have to utilize the time, the unit of times very wisely. Paheli wondered how time was measured when pendulum clocks were not available. We will discuss about this and continuation of this in our next class. Okay. Thank you.